Hello. So continuing with section 2.8, we saw or we learned what are inverse functions and what is the notation, and we saw a couple of examples where the function is given as a listed values, then we can see whether the function is one-to-one or not, like this example that we saw. And in this last example, we discovered this kind of a thing, that the domain of f is the range of f inverse, and the range of f is the domain of f inverse. So they get interchanged because the x and the y get interchanged. So now we have some important properties of inverse function, and first is the same that I just explained up there, that the domain of inverse f inverse is the same thing as the range of v f. So if f is a one-to-one function with domain set A and range of set B, then domain of f inverse, which will be the same thing, which is the range of f, so it will be B, and then range of f inverse will be the same thing as what is domain of f, which is A. Also, there is another property which is shown in number 2 here. What this property is called cancellation property sometimes. Okay. So what it is, basically what it means is that it undoes what one function has done. So if you notice, what is this? This is the composition. This is f inverse composed with f of x. And the other one is f composed with f inverse of x. So what f did to its input, f inverse undoes, so we get back our x. Okay. And in the same way, if you look at this second piece here, so what f inverse did to x, if we apply f on top, then it undoes the work and gives us back x. So if these two conditions are satisfied with any two functions given, if we do this, if we get, so if f composed g of x gives us x, and g composed with f also gives us x, then g is the inverse function of f, and actually basically they are inverses of each other, and f is the inverse function of g. So basically we say that f and g are inverse functions of each other. Again, warning, keep telling you over and over again that the -1 on the power is not an exponent here. It does not mean 1 over f of x. Now later on, when we go to trigonometry, you will see inverse functions. So for example, you might have heard about sine theta, cosine theta, so those kind of things, or sine x, y, as cosine x, tangent x. So if you see something like this, we will have functions sine of x, y is equal to sine of x. So this is like y is equal to f of x. But now the inverse of this function will be the function y is equal to, and we write it as sine inverse x. And we will not think of it as 1 over sine x. That's something, and that is kind of here what we are seeing here as well. Okay, so next, looking at this graph. So the example says sketch the graph of the inverse function for the function given below. So the function given here is 1 to 1, right? Because any horizontal line you can see cross a graph in at most one point. Okay, and the function is restricted. It's starting here at this point. So the function is starting here and ending up there. Okay, so what is the domain of this function? And what is its range? Okay. So the domain is going to be the interval starting at negative 7, right? Starting at negative 7 and ending at negative 2. So that is the domain. And what about the range? So its domain of f is the interval negative 7 to negative 2. And the range of this will be the interval starting at 1 and ending at 6. So it will be 1 comma 6. So now what about the inverse function? Well, this will now become the range of f inverse, and this will become the domain of f inverse. So let us try to graph this. So this is how you will do it. Just mark or write the coordinates of some important or critical points. For example, we will wherever see the function is joining or starting, ending. So I note down the coordinates of those points. So if you want, you can name them as well: A, B, C, D. So the coordinates of A are negative 7, 1. And the coordinate of B are negative 6, 3. And the coordinates of C are negative 4, 4. Coordinates of 5 are negative 2, 6. Okay. Now in the inverse function, we will reverse them. So the point negative 2, 6 will become 6, negative 2. So where will that be? 6, negative 2. So the D point, the kind of the partner or the corresponding point to D will go to 6, negative 2. So let's call it D dash or D prime. So this is 6, negative 2. Okay, this is the one we got from D. What about the others? What about C? So C was negative 4, 4. So it will become 4, negative 4. So 4, negative 4. So this is C prime, and the coordinates are 4, negative 4. Okay, the B is negative 6, 3. So it will become 3, negative 6. last one, which is negative 7, 1. So it will become 1, negative 7. Sorry, this was okay. So the negative 6, 3 becomes. Also, sorry, I think we got this one correct. Did we? So it will be 3, negative 6. That's right. Then we should have 1, negative 7. Okay. Okay. So they are looking. They might look a little bit weird because if you notice here, the grid is not like same. It should have been a square. It looks like a rectangle, so that way the shape might look a little bit different. But basically, that's it. Now we join them, and I will use the same colors as I have for those lines, so that you can see which piece went where. Okay. Okay. So let's see. The blue one is the first one which joins C and D. So this is the blue piece. Then we had the red one which joined B and C. And then we have the green which joins A with B. Something like this. So now what will happen, if you can kind of see it, if I draw a line y is equal to x, which will go through these grid points. So then we should be able to see that if we fold our picture, our graph about this line, then these two functions will map each other or will come on top of each other. So this is the f inverse x function, and that is the f of x function. So basically, another way of defining f inverse is that f inverse graph of f inverse is a reflection of the graph of f about the line. So what is the equation of this line? Y is equal to x. So always this is true, okay? So if we have a function and we want to draw the graph of the inverse function, we just reflect the function about the line y is equal to x and get our graph of inverse function. Okay. I'll do one more example and then we will leave the rest of the examples for third video. So here sometimes we can be given two functions and we want to check whether they are inverses of each other or not. So remember, if you find a function g which is inverse of f, then automatically f will be inverse of g. And how can we do that? We can use the property which we call cancellation property. So if that property is obeyed by both functions, then they are inverses of each other. So we have f of x and g of x. So first thing I do is find f of g of x, or f composite g of x. Which will be, so I'm going to plug in g in here, the function x, f. So I have x cube. So in place of x cube, I have this whole thing. Cube root of x minus 4, and then whole thing cubed plus 4. So if you simplify, we get the cube and the cube cube root and the cube cancel each other. So we are left with x minus 4 and then plus 4. So it gives me x. Now going the other way, g of g composes f. G of f x. So now we are going to place the f function in the g function. So we get cube root of x cube plus 4 minus 4. So we end up getting cube root of x cube, but the cube and the cube root cancel each other, so we get x. So we say yes, g is the inverse function of f. Okay, rest of the examples in the next video.